All right, and then the last section for today is the atomic mass, or the average atomic mass. Again, this is different than the mass number that we talked about yesterday. This is the weighted average of all the different isotopes. So when we talk about the mass number, we're talking about one specific atom. But this guy, we're talking about the actual average of all the possible ones. So just be careful with this. What we do with this is we're going to look at the abundance. So some isotopes are really common, some isotopes are really rare, and we're going to look at that. And then we're also going to use a mass spectrometer, which we'll talk about later. That's kind of how they get these abundances. It's not like we just make them up. They actually get them from these things called mass spectrometers. When we get the average atomic mass, this is what we have on the periodic table. So when you look up oxygen, and it's 15.9994, that's the average atomic mass, and that's where we averaged everything together. So just keep that in mind. All right, there's two types of problems that you can do with these. The first one is pretty simple. The second one is a little trickier, there's some algebra to it. This one you actually did yesterday with the POGIL, but we're just going to practice it. So if you're doing the atomic mass, we have this thing here where we have its percent abundance, 78.99, and then we have what is its mass right here. So when you do a normal average, you just add them up and divide them by 3 because they're each basically equal. This is not equal, so we have to take that into account. So what we're going to do is say, okay, he's 23.98504 AMUs. And we're going to multiply it by how common he is. And he's 78.99% common. So mathematically, that's if we put that as a decimal, it's 0.7899. So that what it does is essentially takes into account how common he is. And then what we just have to do is just do that for each of the different isotopes. So the next one is 24.98584. And he's 10% common, or 0.1000 if we put it in a decimal form. And then the very last guy is 25.98259, and he's 11% common, so he's 0.1101. We put it in our calculator, we're real careful. And if you notice, see how these all have 4, like there's two decimals and 2 before. So that means we're going to have 4 sig figs in our answer. I know we haven't done sig figs yet, but just keep it in mind. So we do this, and he's going to be 24.31. It's a mass, so he's AMUs. And that's our answer. So we took each one, how common is it, and then we put it through here to get the answer. All right. And then the other one we're going to do is just the gallium one for today, and just so you've seen it before. So right here we want to calculate the percent abundance. So in the last one they told us the percentages, 78%, 27%, whatever. This time we need to figure it out. You can only do this type of problem if there's only 2 isotopes that are common. I can't give you like one with 7 or something. You'd have to do multivariables, and that wouldn't be that much fun. So you can only do it with 2. And basically what we have to look at is this is our average one right here, 69.72. That's what we get off our periodic table. And these are each of the isotopes and their percentages, and their masses. So we're going to set it up just like that last problem, but we're going to have to use some algebra. So what we did is we took the mass, so we're going to take that first mass, 68. Oops, doesn't like me. Let's see if it works now. Oh, there we go, 68.9257. And last time we multiplied it by a percent. Well, we don't know the percent, so we're going to say that percent is X. Now we're going to add it to the other guy, 70.9249. And basically, we don't know what his percent is as well. But if we put a Y in, or put in, some other Z or whatever, we couldn't solve it. So what we have to think about is how are they related. So if the first X is if the first guy is 50%, then the second guy would have to be 50%. If the first guy was 60%, the second guy would have to be 40%. So mathematically, we do 1 minus X. Because remember, mathematically, we do percentages as decimals. So if this first guy is 0.3% or 0.3, then this guy would have to be 0.7, vice versa. So that's where that comes from algebraically. And then when we add this up, it's going to have to add up to that average, 69.72. So that's what you have to do. You just have to keep in mind that you're going to have these two things. So then what you do is you actually do some algebra. So the first thing I'm going to do is just kind of carry everything through. So I get 68. Oops, my thing doesn't like me again today. Let's try it again. 68.9257x plus 70.9249 minus 70.9249x equals 69.72. And all I did was I just took and basically went through the math. I just kind of took this and multiplied it through. Then I want to get everything on the same side, so I get my x's on the same side. I get negative 1.9992x equals minus 1.20, my number. So I just got all my like terms together. And then I solve for my x, which is 0.6000. So what does that mean for us? Well, this x is representing a percentage. So what that means is this first guy is 0.6 or 60%. And that means, okay, then what's the other guy have to be? Well, if this guy's 60%, then this guy has to be 40%. And that would be your answer. Now you have to make sure you get it for both of them. You don't want to just get it for one and then forget about the other guy. So you just have to be careful with that. Oh, and just keep in mind, this is 0.6. I don't know where that point went, but that's 0.6.